Hello again. In this short lecture, we're going to discuss NAN equivalent functions. The name gives it away, but these are functions that work on arrays with missing values in them. Many of the functions we examine in this section have NAN equivalents, which work the exact same way, but don't crash or return NAN when the input data is incomplete. Let's elaborate on this concept with a hands-on exercise. Before we start, you can execute these cells to import NumPy and define the 2D array called matrix A. Right. We'll begin our work here with NAN mean, which is the NAN equivalent of mean, but you've probably figured that out already. If we call this function and pass matrix A as the input, we'll get a familiar result, 3.4. In case you don't recall, let's also call the regular mean function as well. We see that both the NAN and the regular version return identical results when the dataset is complete. But let's see what happens when we define an incomplete matrix. In a new cell, we can paste the code we used to define matrix A and change it to matrix B. Then we'll switch out one of the values and let that be the value of 6 here for np.nan. As you know, this is the data type NumPy uses to represent elements that are not a number. As we execute this cell, we will create matrix B, which has this missing value in it. All right, the new matrix looks good. Now, let's call NAN mean for the new matrix. The output is lower than the 3.4 we had earlier, which makes sense since we removed an element greater than the mean. This was the value of 6, which was higher than 3.4. Let's also see how the mean function works with this new 2D array. The output is an NAN, meaning that the regular version does not provide any numeric value when facing incomplete data. Superb! We can explore how results change for other functions like NAN quantile or NAN variance. But the main takeaway here is that NAN equivalent functions are very useful when we have incomplete data. They basically run while ignoring all NAN values in the data. Of course, it would be in our best interest to find and fill any missing values if we have the chance. But NAN functions are a great tool to use in the meantime. Fantastic! We've just completed this section about statistical functions in NumPy. I hope you enjoyed learning not just about them, but also about how programming in Python, and particularly NumPy, can help us put mathematics and statistics into practice. Now that we've gone through some of NumPy's most reliable statistical functions, we're ready to move into a different application of ND arrays, data manipulation. In the next section, we'll explore how we can use NumPy's functions to clean and pre-process datasets and prepare them for future analysis. Thanks for watching.